Good evening, Honors Algebra. This is the flipped lesson for Tuesday, November 15th. It will teach you how to write equations for parallel and perpendicular lines when you're given the line that they are either parallel or perpendicular to and a point that they go through. Now, we've had 2 days of writing equations for lines, so you should be getting pretty good at that. The parallel and perpendicular part will actually be a little bit easier because you won't have to calculate the slope. The slope will be done for you in one case, in the other case you just have to make a small adjustment to it. But first of all, let me get two equations of two lines out here and graph them. Okay, I have the two linear equations written in slope y-intercept form. They won't always be in slope y-intercept form, but not a big deal. You should know how to graph, whether in point slope form or standard form. If you're not sure, come see me. The one equation is y equals negative 1/3 x plus 4. My y-intercept is 4. I'm going to go ahead and plot that. Let's see here. 3, 4, it's right there, my y-intercept. And my slope is negative 1/3. I can either go down 1 and right 1, 2, 3. Down 1, right 1, 2, 3. Or from the y-intercept, I could have gone up 1 and back 1, 2, 3. Up 1 and back 1, 2, 3. All right. So I will draw that line in. Like so. And let me change that. Okay, so there is my red line graphed. Now I'll graph my blue line. And my y-intercept is way down here at negative 5. 1, 2, 3, 4, 5. And my slope is negative 1/3. I can go up 1 and left 3. 1, 2, 3. Up 1 and left 3. 1, 2, 3. Or, of course, I could go down 1 and right 3. 1, 2, 3. Down 1 and right 1, 2, 3. And there I go. I have my line. So I'll draw that in one moment here. And so you see these lines are parallel. Now I knew they were going to be parallel before I started. I knew they were going to be parallel. Look at those two equations. See if you see something that might tell you that they might be parallel. Obviously Sam and Spencer know because they got front-loaded Monday at the algebra party. You know, if I asked you in class what's true about parallel lines, the first thing you want to tell me is that they don't intersect. And in a two-dimensional space, that is absolutely true. But we're working on a deeper level than that. Take a look at those equations. I notice that the slope of the red line is negative 1/3. I also notice the slope of the blue line is negative 1/3. Parallel lines have the same slopes. Parallel lines have the same slopes. Parallel lines have the same slopes. By the way, this is the symbol for parallel. Parallel lines have the same slopes. Okay, so that being said, if I give you the equation of a line and ask you to write the equation of a line parallel to it, it should be a really easy task to do if I tell you a point that the line goes through. So let me get a fresh page out here and an equation. Let's say my equation is y equals 2x plus 6. And hold on one moment. Oh, I didn't realize that was playing that whole time. I apologize, ladies and gentlemen. There was a big dead space there, but that's okay. You saw me typing. I want you to write the equation of the line parallel to the line whose equation is y equals 2x plus 6, and that passes through the point 5, 7. Now, I know some of you have trouble with remembering your x and y, and remember I asked you to write x and y above the coordinates just until you don't need to do that anymore. And we have this equation, y equals 2x plus 6. All right. The first thing I'm going to do, just like on the past 2 days, I'm going to find the slope. Well, the slope is going to be 2, or 2 over 1, but 2 will serve me very well in this. The next thing I'm going to do, and you have two choices. I'll do it two different ways. I'll do it with slope y-intercept form, and over here, I'll do it with point slope form. So if I'm in slope y-intercept form, I'm going to use the equation y equals mx plus b. I'm going to fill in m, I'm going to fill in a y, and fill in an x. And when I do that, I'll be able to solve for b and then write my equation. So let's do that. The y is 7. Where did I get that from? Over here. The m is 2. I'm not writing it as a fraction because the x-coordinate's not a fraction, so I don't need to use the fraction form of it. I put in the x-coordinate, which is 5, plus b. So therefore 7 will equal 10 plus b. And then if I subtract 10 from each side, I will get that b equals -3. All right, now that I know the slope and the y-intercept, I'll get y equals 2x minus 3. That is the equation of the line that is parallel to the green line, but it also passes through the point 5, 7. Those were the restrictions of the problem. All right, to do it in point slope form, in some ways might be a touch easier. First of all, I need to know the slope. Well, that's 2. I already have that. M equals 2. So point slope form, I will take y, and I will subtract the y coordinate, which is 7. That will equal 2 times the quantity of x minus the x coordinate, which is 5. I will simplify this by first distributing 2x minus 10. And then I will get the y alone by adding 7 here and to the -10. When I do that, I will end up with y equals 2x minus 3. And look, that matches this equation here. They are the same. It doesn't matter which way you choose to do it. Mr. Newman, the geometry teacher, honors geometry, mentioned that point slope form was something that the kids don't seem to retain very well. You might want to practice point slope form on this for a little bit. Okay, now I'm just going to prove to you that, oh dear, looks like Spencer's following his instructions and sending me an email. Let me close this so no more pop up. Thank you, Spencer. All right, I'm going to go ahead and bring up my graphing calculator here. Hold on one moment. Sorry about that. I can't seem to find my graphing calculator on here. I thought I had one installed, but no matter. I'll just graph them manually. I will do the green one in green. It's not easy, you know. 1, 2, 3, 4, 5, 6. Being green, that is. The graphing's quite simple. Up to right 1. Up to right 1, back from the y-intercept down to left 1, down to left 1. It's not easy being green. Having to spend each day the color of the leaves, when I think it could be nicer being red or gold or yellow or something much more colorful like that. Okay, enough of the bad singing for you. All right, so there is my green line. Now watch the blue line. I'm going to go through the y-intercept of -3, and I will go up to right 1, up to right 1, up to right 1. I can go down to back 1. Now here's a really cool feature of the smartboard. I can prove these lines are parallel because if I clone this green line and I place it on the points, it fits perfectly. If they weren't parallel, that would not happen. All right, so I'll change its color just so you can tell it's the blue line. And there we go. And there you go, they are parallel. Now, by the way, remember the point that my blue line had to pass through? That was the point 5,7, right? See it right here, 5,7. Watch this. If I come down here and I count over 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. And there it is, going right through the point. Of course, it might be a good idea for you to see it if I extend it, but there it is. So I wrote the equation of a line parallel to an original line, knowing what point it had to pass through. Real easy to do. Now, I want you to take these two equations, this new page here. Let me get out my graph paper. And I'm going to give you two new equations, and I want you to graph those. So hold on 1 second while I try to find them. Go ahead and pause the video. Try to graph these two equations on your own. Make sure you don't make a mistake, and watch and see what happens. All right, so hopefully if you graphed, you got something like this. These two lines have a very special relationship. I hope you're shouting out what that relationship is. These two lines are perpendicular, meaning they form 4 right angles where they cross. Yeah, they form 4 right angles. Now, again, I knew they were going to be perpendicular just by looking at the equations. Check this out. The slope of the green line, 2/3. The slope of the blue line, m equals -3/2. Perpendicular lines have special slopes. The slopes are negative reciprocals of each other. I'll say that again. The slopes of perpendicular lines are negative reciprocals of each other. The slopes of perpendicular lines are negative reciprocals of each other. Hopefully you wrote that down. Now that you know that, you're equipped to go ahead and find a new equation. If I give you the original equation of y equals 4/5 x minus 2, and I ask you to, okay, so this time I want you to write the equation of the line perpendicular to the line whose equation is y equals 4/5 x minus 2, and that passes through the point 4, 6. Very much the same problem. The first thing I'm going to do is going to be to find the slope. Well, when I'm in slope-y-intercept form, that's easy enough. Now remember, you won't always be in slope-y-intercept form. Sometimes you'll be in standard form or point-slope form. You might have to find the slope in a different way. All right, now I need the slope of the perpendicular line. Well, because Mr. Lawrence only said it about 8 times, probably more like 5. The slope of perpendicular lines are negative reciprocals of each other. I'm going to change the sign, make my slope negative. My original slope was positive, and I'm going to use the reciprocal. In other words, I'm going to flip the fraction. Now that I know that, if I know an x and a y, I could do it 2 ways again. Y equals mx plus b, or point slope form. And again, I'm going to come over here and I'm going to put x above the 4 and y above the 6, and that's for the benefit of those of you having a little trouble with that. Okay, so again, I will do it 2 different ways. I will do point slope form over here, and over here I will do slope y-intercept form over here. Okay, so for point slope form, I will write y minus the y value, which is 6, equals -5/4 times the quantity of 4/1. Oh no, that is not correct. Sorry. X minus 4, and I'll leave it like that. I'll go ahead and solve that really quick. First, I have to distribute. Y minus 6 is going to equal -5/4 x. -5/4 times -4 would be +5. How do I know? Because the 4/1 would cancel with the 4 in the denominator. I'll add 6 to each side, and my new equation becomes y equals -5/4 x plus 11. For those of you who'd rather do it in slope y-intercept form, I will fill in my y value, which I believe is 6. My slope is -5/4. I have to multiply it by the x coordinate, which is 4/1, because 5/4 is a fraction, so I'm going to use 4/1. I'll do plus b. 6 will equal, those 4's will cancel. I'll get -5 plus b. I'll add 5 to each side. B will equal 11. Then I have to remember to write y equals -5/4 x plus 11, and presto, I get the same equation. I'm not actually going to graph it now in interest of time, but you go right ahead and finish graphing it. If you like, you get the two lines. They will end up being perpendicular. That is, either the red or the blue equation will be perpendicular to the black one. And if you did the red one, it'll pass through the 0.46. If you did the blue one, it will also pass through the 0.46. So this should be really simple, especially after the great job you guys have done Monday and Tuesday in class on writing equations. I can't find my recording to pause it. All right, that'll be the end of this lesson. Mr. Lawrence signing off.